Atoms in the Void, a story of wonder and curiosity. In the year 454 BC, a curious Greek named Herodotus set foot in the ancient land of Egypt. The towering pyramids left him speechless. So did the statues at Thebes, monuments that rose 60 feet high, watching over the Nile like silent gods from another age. Everything felt impossibly old to him. Egypt's golden days had long since passed, its former glory now buried under Persian rule. Herodotus, however, came from a younger world, the energetic, up and coming Greek civilization that would, in just a century, sweep through Egypt under the command of Alexander the Great. By then, Greek thinkers and writers were spreading their influence across the eastern Mediterranean. They had recorded the tales of Homer, the legendary blind poet, who told of Greek warriors hiding inside a giant wooden horse to bring down Troy, and of Odysseus's epic journey home, filled with monsters, magic, and clever escapes. These Greeks were not just warriors or storytellers. They were masterful shipbuilders, bold traders, and above all, thinkers. Among the earliest of these thinkers was Thales of Miletus, a man of many hats, merchant, astronomer, mathematician. Although none of his writings survived the passage of time, later authors preserved his legend through quotations and stories. One tale describes him so engrossed in watching the stars that he fell straight into a well. In another, he showed just how shrewd science could be. Foreseeing a bumper olive crop, he rented all the olive presses early when no one else saw the value. When harvest came, he made a fortune. Thales may have been absent minded, but he wasn't absent of insight. Some said Thales brought Egyptian mathematics back to Greece, perhaps during a visit to the land of the pyramids. Others credited him, perhaps too generously, with predicting a solar eclipse. Regardless of what's myth and what's fact, one thing is clear. Thales sought to explain the natural world not with gods and miracles, but with reason and observation. While the Egyptians saw the Nile's floods as divine acts, Thales believed they had natural causes, such as water heating beneath the Earth's surface. To him, water was the fundamental substance, and the Earth floated on a vast ocean. It may sound strange now, but it was a radical departure from myth. Another thinker from Miletus, Anaximander, offered a different view. He believed that fire, not water, was the essential substance. Then came Empedocles of Sicily, who proposed something more familiar to us, that all things are made from four basic elements: air, earth, fire, and water. This idea stuck around for nearly 2,000 years, guiding philosophers and physicians alike deep into the Middle Ages. But not everyone agreed with these elemental theories. A group known as the atomists proposed something altogether different and much more radical. They believed that the universe was made not of earth, air, fire, or water, but of tiny, invisible, indivisible particles called atoms. The most famous among them was Democritus, who lived around 420 BC. Though much of his work has been lost, fragments quoted by later thinkers reveal a bold and fascinating vision. Democritus imagined a universe filled with countless atoms moving through the void, an endless sea of empty space. These atoms, eternal and unbreakable, came in various shapes and sizes. It was their arrangement, he believed, that gave rise to the textures, colors, and flavors of the world we experience. But in truth, he said, reality consists only of atoms in the void, matter and space. Everything else, our senses, our perceptions, were just interpretations by the human mind. The idea that life in the cosmos came about not by design, but by chance and necessity, made many uncomfortable. Atomism suggested that living things evolved through a kind of cosmic trial and error. In one amusing version, body parts, arms, legs, eyes, once floated around independently, forming mismatched creatures, a fish with an elephant's trunk or a cat with a dog's leg. Those combinations that didn't work simply didn't survive. Over time, natural pairings endured. It was a crude but oddly forward-thinking notion of evolution. Another theory held that all life had once emerged from an ancient primordial slime. Not exactly poetic, but perhaps more plausible. These were bold, even bleak, ideas. Many Greeks, including the great philosophers, preferred to believe in purpose, beauty, and divine order. Atomism was not widely embraced, but it wasn't forgotten. Centuries later, in Rome, the poet and philosopher Lucretius would revive these ideas in his masterpiece De Rerum Natura, On the Nature of Things. Written around 100 BC, It was a sweeping poetic exploration of the universe built entirely from atoms. Lucretius described the heavens, the earth, and the rise of human civilization through this lens. His work would echo across the ages. Meanwhile, Greek science flourished. Many brilliant minds emerged over a 1,000-year span, shaping the way we understand the world even today. There was Euclid, the great geometer, who lived around 300 BC. Though geometry had earlier roots, Babylonians had explored it centuries before. Euclid distilled its principles into an orderly, elegant system. His textbook, Elements, became the foundation of geometry. From points and lines to angles and surfaces, Euclid's clarity has stood the test of time. Even today, students study his plane geometry, marveling at its precision. Then came Eratosthenes, another genius from Alexandria, born around 284 BC. He was the first to measure the Earth's circumference, and he did it with nothing more than shadows and geometry. Knowing that on the summer solstice the sun was directly overhead in Syene, modern-day Aswan, he measured the sun's angle in Alexandria, which lay roughly 5,000 stades to the north. With this data, he calculated the Earth's total circumference as 250,000 stades, astonishingly close to the modern figure of 24,901.55 miles. Yes, Eratosthenes knew the Earth was round. And finally, there was Ptolemy, who lived in Alexandria around 100 AD. A true polymath, he studied everything from music to optics. But his legacy lies in his great work, the Almagest, a monumental treatise on astronomy. There, he charted the stars and described the movements of the planets, sun, and moon. Like others of his time, he believed that the Earth stood at the center of the universe, with everything else moving in perfect circles around it. To make this model work, he added clever corrections, small tweaks to account for the irregularities people observed in the sky. Although we now know that the Earth orbits the sun, Ptolemy's model remained dominant for over 1,000 years. Translated into Arabic and Latin, the Almagest became essential reading for astronomers across the Islamic world and medieval Europe. To many, Ptolemy stood shoulder to shoulder with Aristotle, Hippocrates, and Galen, the giants of ancient science. And though we remember each of them in separate chapters, their ideas together formed the backbone of early scientific thought. The ancient world may not have had microscopes or rockets, but it had something just as powerful: imagination, logic, and the courage to ask bold questions about the universe.